In these problems, we are looking at some rational functions. So they're going to have some discontinuities. You can see this one, x squared plus 7 over x, is not defined at x. So we got to keep that in mind. And we're trying to find where it's concave up, concave down, and where it has what are called inflection points. And if this is a new concept to you, concavity when it comes to curves should be pretty intuitive to figure out. If I have a parabola that's shaped like that, the concavity, the pushed inness of it is pointing up. This is a concave up parabola. If you have one that's upside down, it's concave down. If you look at a curve like x cubed, it's actually concave down over here and concave up over here, and it switches right there. That's what we call an inflection point. So where the concavity changes, that's an inflection point. For this first problem, what I've done is actually graph this on a graphing calculator so we can look at it. This is a rational function, so it's got a discontinuity. In this case, it's at 0. It goes down to negative infinity on the left and up to positive infinity on the right at 0. And then it's got a chunk over here on the right. This is all concave up on the right. And on the left, it's a little subtle to see, but it's actually concave up here in this area. And then right here is an inflection point, and it shifts to being concave down. So hopefully you can see that and get a sense of that. Let's figure out how we solve this or find this information out without looking at a graph, just by having the equation. We've been using the derivative of a function to determine where a function is increasing or decreasing. If you want to determine where it's concave up or concave down, you have to take the second derivative. So let's go ahead and start deriving here. I'm going to rewrite this as x squared plus 7 times x to the minus 1. And let's take the first derivative of that. We're going to get 2x plus, no, not plus, minus 7 x to the negative 2, just using the power rule there. Now let's take the second derivative, and I'm going to get 2 minus 7, plus 14 times x to the negative third. I'm just going to go ahead and rewrite that as a fraction, as a rational function here. So plus 14 over x cubed. Hopefully I did that right. You can try it yourself and double check. So that's our second derivative. And just as we looked for points where the first derivative was 0 so that we could know where to check, which regions to test, whether they were positive or negative, we're going to do the same thing here. So we're going to look for where there's an inflection point. Where there's an inflection point is where the second derivative equals 0. So how do we do that? We want 2 plus 14 over x cubed to equal 0. Well, let's do some solving. I'm going to subtract 2 from both sides. Now I've got 14 over x cubed. Now I'm going to multiply both sides by x cubed. So I'm going to get 14 equals negative 2x cubed. Then I'm going to divide by negative 2. That's going to give me a negative 7 equals x cubed. Now I can take the cube root. So we want the cube root of a negative 7 or a negative cube root of 7. Same thing. So that is probably going to be our inflection point. We should test the regions to make sure. And then one other thing to remember is that this function is undefined at 0. So that's another point for us to test. So if I were to graph this out here, I'd have 0 over here. I'd have the negative cube root of 7 over here. And we want to test all three of these regions. Now the cube root of 8 is 2. So I know that negative 2 is to the left of this. So if I want to test this region to the left, I can put a negative 2 in here. And what we would get is 2 plus 14 over, and negative 2 cubed is negative 8. So 14 over negative 8, that's less than 2 though. So this is going to remain positive. So it looks like we're concave up on that interval there. So concave up here. Let's test this region in between, and let's see, a good number there would be negative 1. So let's plug negative 1 in here. That's going to be 2 plus 14 over negative 1, or 2 minus 14. That's definitely negative. So this is down, concave down in this region. And then let's test over here to the right of 0. I'm going to put in a 1. That's 2 plus 14. That's positive. So this is up. Okay. And if we look back at our graph, you can see over to the leftmost part is where it's concave up. It shifts here to concave down. And then over here, it's all concave up. So it looks like we did that right. The second derivative worked out for us. Now, let's see, intervals on which it's concave up. So there's 2 of them. We're up from negative infinity to negative cube root of 7. That's one of them. And the other is 0 out to infinity. So like that. So those are the places it's concave up. It's concave down just in this little section here between the negative cube root of 7 and 0. And then it says, find the inflection point. So inflection points, I said again, are where the concavity changes. They also have to be actually on the graph. So if there's a discontinuity, it's not going to be considered an inflection point. We know there's a discontinuity at 0, so that is not going to be an inflection point. So the only inflection point we've got here where it changes from concave up to concave down is negative cube root of 7. But they want this as an ordered pair. Let's find the y value. We have to go back to the original function. So we've got negative cube root of 7 quantity squared plus 7 over the cube root of 7. Let's see, I think we can do some work with this. I'm going to multiply, this is 7 to the 1/3. I'm going to multiply by 7 to the 2/3 over, negative cube root of 7. I'm going to multiply by negative 7 to the 2/3 over negative 7 to the 2/3. What's going to do on the bottom is just create a positive 7 down here. This is 7 to the 1/3. This is 7 to the 2/3. It becomes 7 to the 1. Up here, we're going to have a negative 7 times 7 to the 2/3. And then those 7s are going to cancel. So that's just negative 7 to the 2/3 power. And then over here, oh, well, isn't that convenient? This, the cube root of 7 squared, is going to be a positive 7 to the 2/3 power. 7 to 2/3 minus 7 to 2/3 equals 0. So our y coordinate is 0. And that is what we were seeing on the graph. It looked like that was our critical, or inflection point, I mean, where the concavity changes. So that is how to find intervals of concavity, where it's concave up, where it's concave down, where the inflection point is, where it changes concavity, by using that second derivative.